लास्ट टाइम हमने कहाँ तक किया था? Did we start with components of vectors or not? Started, huh? हाँ. So we were discussing about components of vectors. Right? So any vector can be expressed as the sum of two other vectors, provided that I can draw a parallelogram, and I can actually draw infinite parallelograms for which the given vector, the black vector, is a diagonal. The moment I draw a parallelogram for which the given vector is a diagonal, then these two vectors, they add up to the given vector, right? हाँ, लाउडर हो जाएगा. सुबह सुबह है अभी, आप हो जाएगा लाउडर. So if this is vector A, right, and if this is vector B, and if this is vector C, then vector A is equal to vector B plus vector C. Right? I mean, this was the purpose of showing you the parallelogram law of addition, that you realize that two vectors along a parallelogram, right, will add up to the vector which is drawn along the diagonal. अब इससे पहले क्या हम कर रहे थे कि हम पहले पैरेललोग्राम बना रहे थे फिर डायगोनल बना रहे थे, लेकिन अभी क्या किया मैंने, पहले डायगोनल बना दिया फिर पैरेललोग्राम बनाया. So basically it's like, saying that 3 plus 4 is 7, or saying that 7 is equal to 3 plus 4. Okay. So I'm just trying to rub this part out. Now, if we have a vector A, right, and if we draw a coordinate axis, that means we draw the parallelogram for which vector is a diagonal, but this time the parallelogram is a rectangle. I can always do that. And the two sides of the parallelogram, which are perpendicular to each other now, lie along a particular chosen XY axis. Right? So this is the x-axis, this is the y-axis. Then this guy is called the x component of vector A. This guy is called the y component of vector. Right? So what is the difference between this and the previous diagram that I had drawn? There is no difference except for the fact that previously I had drawn a random parallelogram for which the vector A was a diagonal, and this time I have drawn a rectangle for which the vector A is a diagonal. Right? So if AX plus AY is equal to A and AX and AY are perpendicular to each other, then AX and AY are called components of A. Right? So if you have two vectors which add up to the original vector and they are mutually perpendicular to each other, then those two vectors are called the components of the original vector. And like I showed you in the last class, and I hope all of you remember, that it is not only along this xy axis, but along any xy axis, any two mutually perpendicular axes, that I can find the components of A. Right? So in this case, we have AX dash and AY dash, AY dash, AX dash. कोई भी दो म्यूचुअली परपेंडिकुलर लाइंस के अलॉन्ग हम कंपोनेंट निकाल सकते हैं. ठीक है, कैसे निकालना है ये मैं आपको बता देता हूँ. I'm going to change the slide now. Okay, you can take a screenshot if you wish. I'm going to change the slide. So supposing that I give you a vector A, right? And I ask you to find the components of A along a particular axis. So what you are going to do is you are going to draw that particular axis. In this case, let's say that this is the x-axis, this is the y-axis. Of course, the axis must be perpendicular to each other. Let's label the axis. So this is the x-axis, this is the y-axis. Please note कि xy axis टेढ़ी है. Normally हम horizontal, vertical xy axis में ही काम करेंगे. लेकिन ये necessary नहीं है. It is not necessary. Okay, especially when we are dealing with Newton's laws of motion, you will see that we will be forced to use tilted axis, especially when we are dealing with inclined planes. Inclined plane पे एक block को रख के release कर दिया. So the axis there that we will require will be an axis which is parallel and perpendicular to the inclined plane. Okay, so here the axis is inclined. Here the axis is straight on. is not horizontal and vertical. To find the components, what you have to do is you have to drop a perpendicular from the tail of the vector onto the, you have to drop a vector, sorry, you have to drop a perpendicular from the tail of the vector to the x-axis, right? And then from the head of the vector onto the x-axis. Then from the tail of the vector to the y-axis, and the head of the vector to the y-axis. Now, you can draw an arrow like so. This would be the x component of the vector A, and you can draw an arrow like so. This would be the y component of vector. Right? So what are you doing to find components? What are you doing to find components? You are just dropping perpendicular from head and tail of vector on n क्यों आया रहा? On the chosen axis. Right? Anybody who does not understand this, please say no. Please type no. You have an arrow, you have a coordinate axis. वही तो करता है ना. You have an arrow, you have a coordinate axis. आपने arrow के tail से x और y axis पे perpendicular ड्रॉप किया. आपने arrow के head से x और y axis के ऊपर perpendicular ड्रॉप किया. ये जो दो perpendicular lines x axis को कट कर रही हैं, आपने इन दो perpendicular lines के बीच में arrow बनाया, वो x component हो गया. जो दो perpendicular lines y axis को कट कर रही हैं, उनके बीच में arrow बनाया, वो y component हो गया. Right? Okay. I am going on to the next slide. So this time, I want you to do this. We have the xy axis, x-axis, y-axis, okay, and we have vector A. In fact, I want to draw the y-axis here. So we have vector A, we have vector B, okay, we have vector C, and we have vector D. Right? So I want you to draw the components of these four vectors in your copies, of course. I will draw the vectors for A. Right? So what I do is I drop perpendiculars from the head and tail of A. Now, instead of drawing the component vectors on the axis itself, like I have done, I will draw the vectors like this. Right? Remember that I can move vectors provided that I'm not changing their magnitude and direction. So this is the vector AX. This is the vector AY. Can you draw the X and Y component of B, C, and D in your copybook? हाँ भैया, एक ग्राफ में बना लो, अलग अलग बना लो, क्या फर्क पड़ रहा है? कोई फर्क नहीं। हो गया, डन. So for the vector B, I'm not going to drop a perpendicular on the y-axis. I don't need to do it. I'll just draw a rectangle like this. This would be the y component of B. But what is so special about the x component of B? क्या special है x component of B के लिए? What is so special about the x component of B? बनाया ना सबने B के लिए x component. Special क्या है? How is it different from the x component of A? How is it different from the x? Yes, very good. Yes. So, vector of the x component of B is equal to this. What about the C vector? It has, well, I mean, let's not say different direction. Let's just say that it has the opposite direction. Right? Vector C के लिए ये x component हो जाएगा और ये y component हो जाएगा. वेक्टर D के लिए ये x component हो जाएगा और ये y component हो जाएगा. Right? So please notice what happens for drawing the components of any vector. What I do is I draw a rectangle, right? और अगर आप चाहो तो अलग अलग डायग्राम में, if you want, and I hope some of you have done this, अलग अलग डायग्राम में आप ABCD वेक्टर का ऐसे डायगोनल ऐसे कंपोनेंट निकाल सकते हैं, राइट? You will get the same, absolutely the same answer. The answer will not be different. मैंने अगर C वेक्टर के लिए ऊपर से CX बना दिया, हाँ कोई फर्क नहीं पड़ रहा. अगर मैंने C वेक्टर के लिए ऊपर से CX बना दिया और आपने इधर बनाया हुआ है, कोई फर्क नहीं पड़ता. या मे बी किसी ने इधर बनाया हुआ है, कोई फर्क नहीं पड़ता. You are absolutely right. We are all absolutely right. I mean, you look at these three arrows, arrow 1, arrow 2, arrow 3. they are all the same. You don't need to worry कि आपने कुछ different बनाया है. Different आपको worry आपको कब करना पड़ेगा अगर आपने ऐसा बना दिया. ये गलत है. This is wrong. C वेक्टर का जो x component है, that is pointing towards the negative x direction. Okay. तो B और C vectors के x component they are pointing towards negative x direction. C vector and D vector के y components are pointing towards the negative y direction. कुछ पैटर्न दिखाई दे रहा है, कोई याद आ रहा है इससे जरा? अगर आप ध्यान से ay ax bx by cx cy dx dy देखो, कुछ याद आ रहा है? कुछ पुरानी चीज स्ट्राइक कर रही है? हाँ, एनीबडी? रजत तो कहाँ से कहाँ ले जा रहे हो? हाँ हाँ हाँ, यस 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 यस, absolutely right. Yes, it is the Cartesian system. So the vector A, although we should not say it like this, but the vector A sort of lies in the first quadrant. Therefore, if you look at the components, they are both pointing along the positive direction. Vector B is sort of pointing in the second quadrant wala direction. Therefore, उसका x component जो है वो negative x के along point कर रहा है और y component positive y के along point कर रहा है. Second quadrant में remember that कोई भी coordinate minus x comma plus y होता है. Vector C third quadrant की तरफ point कर रहा है. Please remember, vector को नहीं बोल सकते हैं कि किस quadrant में, ठीक है ना? वेक्टर को ये नहीं बोल सकते ये वेक्टर थर्ड क्वाड्रेंट में है. ये बोल सकते हैं कि ये वेक्टर थर्ड क्वाड्रेंट की तरफ पॉइंट कर रहा है, क्योंकि यहां तो सारे वेक्टर फर्स्ट क्वाड्रेंट में एग्जिस्ट कर रहे हैं. तो वेक्टर्स कैन एग्जिस्ट इन एनी विच क्वाड्रेंट दे वांट, राइट, बट दे पॉइंट इन ए पर्टिकुलर क्वाड्रेंट, राइट. तो वेक्टर सी थर्ड क्वाड्रेंट की तरफ पॉइंट कर रहा है, तो उसमें x कंपोनेंट और y कंपोनेंट दोनों नेगेटिव x एक्सिस नेगेटिव y एक्सिस चले गए. और वेक्टर d फोर्थ क्वाड्रेंट की तरफ पॉइंट कर रहा है, इसलिए उसका x कंपोनेंट पॉजिटिव है और y कंपोनेंट नेगेटिव, राइट. ठीक है ना, राइट. ये आया सबको समझ में? एनीबडी हु इज नॉट अंडरस्टैंडिंग प्लीज टाइप नो and the specific thing that you are not understanding. Row number 51. What is it that you are not understanding? We have an arrow. We have to draw a rectangle such that that arrow is a diagonal. And then along the sides of the rectangle, we have to draw two arrows. These two arrows will be called the components of the vector. Row number 51. Direction of components. तो वो याद है ना कैसे पैरेललोग्राम लॉ अप्लाई करते हैं? Vector itself is pointing towards Vector itself is pointing towards, उससे कोई फर्क नहीं पड़ता. मेरे पास ये XY एक्सिस है, ये वेक्टर कौन से क्वाड्रेंट में है? In which quadrant is the vector? Third, not the first, third. Okay. So you can say for a moment that the vector has been drawn in the first quadrant. ठीक है भाई, आई विल एग्री। फिजिकल प्रेजेंस, हाँ, फिजिकल प्रेजेंस इस वेक्टर का फर्स्ट क्वाड्रेंट में है, लेकिन ये वेक्टर है कहाँ का, ये वेक्टर के कंपोनेंट्स कैसे रहेंगे, तो ये वेक्टर थर्ड क्वाड्रेंट की तरफ पॉइंट कर रहा है, इसलिए इसके जो कंपोनेंट्स होंगे, दिस कंपोनेंट्स ऑफ द वेक्टर विल बी लाइक दिस। और इसमें कोई कंफ्यूजन नहीं होना चाहिए, क्योंकि मैंने हमेशा से बोला था कि ये देखो, अगर आप वेक्टर्स को ऐड कर रहे हो, रिमेंबर, then the vectors are drawn together. That means the tails must be coinciding, right? These vectors are drawn together. The tails must be coinciding, and the coinciding tails tells us, tells us what is the direction of the components going to be. So you should never get confused, क्योंकि ये जो XY एक्सिस है, राइट, ये वेक्टर का फिजिकल प्रेजेंस उस एक्सिस के रिस्पेक्ट में किधर है, दैट डज नॉट मैटर, बिकॉज आई कैन जस्ट एज वेल ड्रॉ द XY एक्सिस लाइक दिस। अब क्या बोलेंगे, किधर आ गया ये वेक्टर, यू अंडरस्टैंड। कोई और बंदा आया, उसने बोला नहीं नहीं नहीं, मेरी तो XY एक्सिस जो है वो ऐसे है, अब किस क्वाड्रेंट में आ गया ये, तो फिजिकली ये वेक्टर किस क्वाड्रेंट में है, ये इनकॉन्सिक्वेंशियल है। ओके, प्लीज ट्राई टू अंडरस्टैंड व्हाट आई एम सेइंग। फिजिकली ये वेक्टर किस क्वाड्रेंट में एग्जिस्ट कर रहा है, ये इनकॉन्सिक्वेंशियल है। जैसे कि यहाँ पे चारों वेक्टर्स फर्स्ट क्वाड्रेंट में एग्जिस्ट कर रहे हैं, existence of a vector in a quadrant is inconsequential, right? What is important is where the vector is pointing, in which direction is the vector pointing, that is important. Okay? हाँ भाई रजत, कुछ
सर अभी जो आपने बताया वो रिपीट कर दो ना, मैं डिस्कनेक्ट हो गया था।
मैंने क्या बताया,
इनकॉन्सिक्वेंशियल आप क्या बता रहे थे, वो रिपीट कर दो ना सर।
वेक्टर जिस क्वाड्रेंट में फिजिकली आपने बनाया है वो इनकॉन्सिक्वेंशियल है। जिस क्वाड्रेंट में वेक्टर फिजिकली एग्जिस्ट कर रहा है वो इनकॉन्सिक्वेंशियल है, राइट। क्या मैटर करता है, वेक्टर किस क्वाड्रेंट में पॉइंट कर रहा है, वेक्टर की डायरेक्शन किस क्वाड्रेंट में है, दैट इज व्हाट मैटर्स। ओके, अभी आया समझ में। रोल नंबर 51, roll number 51, you understood this, very very simple, it's not difficult at all। जब difficult वाली चीज आएगी तो I'll tell you that it is difficult, right? So you should remember that vector की physical presence किस quadrant में है does not matter, vector किधर point कर रहा है, हाँ, mutually perpendicular होना चाहिए, वेक्टर किधर पॉइंट कर रहा है ये मैटर करता है, एंड दैट विल डिसाइड द डायरेक्शन ऑफ द कंपोनेंट। प्लीज नोटिस दैट फॉर ऑल वेक्टर्स आई हैव ड्रॉन द वेक्टर एंड द कंपोनेंट सच दैट their tails are, all of their tails are coinciding, right? एक, हाँ, क्या पूछा भैया, मैं देखा नहीं। This vector is pointing towards which direction? Which vector बेटा? कौन सा vector? Let me just get the, let me just get the last page. हाँ बोलो, कौन सा vector? A B C D किसकी बात कर रहे हो? ABCD किसकी बात कर रहे हैं? इसमें कंफ्यूजन आ रहा है. बिफोर दिस, हाँ अब बताओ. हाँ, क्या क्या पूछना है? टेल मी. हेलो. अरे आफ्टर दैट क्या बिफोर आफ्टर कर रहा है भाई? देखो, मैंने ये वाला मैंने मिटा दिया है. आई रब दिस आउट बिकॉज उसका कोई वो नहीं था, मतलब नहीं. हाँ हाँ भाई, शेयर तो मैं करता ही हूँ हमेशा. ओके, चलो आगे बढ़ रहे हैं. आगे बढ़ रहे हैं. ठीक है, प्लीज रिमेंबर दैट द फिजिकल existence of the vector, the quadrant in which it physically exists, does not matter. Okay. So this is the y-axis, this is the x-axis. We are going to look at some more properties of components, right? Please, please, please don't get disconnected. This is very important. This is the vector A, and we are interested in finding the components of A along the xy axis. So I will simply complete the rectangle. This vector I will designate as AX. This vector I will designate as AY. Right? And I want to talk about the properties of the components. So the first property is that AX plus AY is equal to A. So the first property is that the vectors, they add up to the vector A, right? अभी अभी यूज ऑफ कॉम्पोनेंट अभी बताता हूं मैं. अभी रुक जाओ, क्यों बेचैन? मैं बोल रहा हूं, इंपॉर्टेंट है, इसको ध्यान से सुनो. फोकस, पे अटेंशन. नाउ the distance from here to here, right? This will be mod of AX. Right? This is the mod of AX. The distance from this point to this point is the mod of the vector AY. And the length of the blue arrow is magnitude of A. So what do you think is the second property? Now please type. What do you think is this? Or don't type it. Just don't type the property. Just tell me ये property कहाँ से आएगी? Which theorem will give me the second property? Very good. Very nice. Yes, yes. Yes, good, good. Absolutely right. Pythagoras theorem. There is a right angle triangle that I can see. for which I know all the three sides. Obviously, it is going to be the Pythagoras theorem. So the second property is that the magnitude of a square is equal to the magnitude of the x component square plus the magnitude of the y component square. The second property here. Third property के लिए I will say that the angle between the vector A and the x-axis is theta. Third property के लिए I will say that the vector between the angle A and the x-axis is theta. If that is so, then what is the definition of cosine theta? I'll write it here. What is cosine theta? Please type and tell me what is cosine theta. Yes, very good. Yes. Huh? AY upon A? AY upon A कैसे हो जाएगा? Base upon hypotenuse तो होता है ना बच्चा, मतलब I'm sure you know this, base upon hypotenuse, we all agree with this, but what is the base here? What is the hypotenuse here? What is the base here and what is the hypotenuse here? Yeah, so cosine theta is equal to mod of AX upon mod of A, right? Magnitude of AX upon magnitude of A. So the third property tells me the magnitude of the x component. I already know the direction of the x component. The direction of the x component is towards the positive x direction. But mod of ax, ये क्या हो जाएगा? Mod of ax will be what? Magnitude of a multiplied by cosine theta. And what will be the magnitude of the y component? What will be the magnitude of the y component? Yeah, it will be magnitude of A into sine theta. Okay. Now I'm going to ask क्यों भाई theta 45 क्यों है? ये कहाँ से आया? Why do you think theta is 45? What is the rationale behind it? Why do you think theta is 45? Why say theta is 45 and why not say length of the blue arrow is 1.5 inches? So theta is any angle between 0 and 90. Later on, we'll see that it is any angle between 0 and 360. Okay. Now, this is the make or break point. Okay. I mean, if somebody has not understood this, what the content on the screen, if you have not understood the content on the screen, then whatever I'm going to teach now will be ineffectual. So please type no and the specific misunderstanding of the content on this page, right? So, if we have two vectors like this, then how are we going to add these two vectors? ये जो रेड वाला वेक्टर है इसको हम ऐड कैसे करेंगे? रोल नंबर 21, roll number 21. How will I add these two red vectors? Roll number 21. Please type your response. How will I add these two vectors? Parallelogram. Please tell me that if these two red vectors are नहीं मैं ग्राफिकली ऐड करना चाह रहा हूँ ना, ग्राफिकली वेक्टर्स गिवन है, मैं ग्राफिकली ऐड करना चाह रहा हूँ. So if I use the parallelogram method, I get this as the answer. So if this vector is ax and if this vector is ay and if this vector is a, then the parallelogram method tells me that vector A is ax plus ay. Is this understood? Rule number 21. हाँ एक मिनट. हाँ बोलो.
But इसमें earlier we used to do that Pythagoras theorem with cos theta that we used to do. So how vector A is equal to vector ax plus vector ay? Like parallelogram method I know, but how it is so? There is also theta.
कहाँ है थीटा?
Sir, लेकिन a vector inclined है ना, like with some angle. So
थीटा कहाँ है बताओ ना.
sir, this one a ax. Can you just name the
No, I will not. And since I will not, that means that the concept of theta has not arisen, right? अगर concept of theta है ही नहीं यहाँ पे, तो will you agree that ax plus ay is equal to a? भाई
Sir,
parallelogram method से ये satisfy हो रहा है या नहीं हो रहा है? मतलब the whole purpose of components is that the vectors along vectors along the sides of a rectangle we have to draw such that the original vector is along the diagonal. ये आया था समझ में जब मैंने बोला था.
so can you repeat?
Wait, I'll just put on that slide. I'll just put on that slide. ये वाला आया था समझ में, ये फर्स्ट स्लाइड आया था समझ में.
हाँ.
क्या समझ में आया?
If they are perpendicular to each other.
हाँ जोर से बोलो. What did you understand from this?
Ax and ay are components of A, and if because they are perpendicular to each other.
देखो मैं तुम्हें बता रहा हूँ क्या होता है. See, when you, I think we discussed this last time also. आप सब्जी खरीदने गई, आपने आलू खरीदा और आलू का कॉस्ट आया 16 रुपीज. अब 16 को we can express as 10 plus 6, right? Is this wrong or right?
Yes.
नहीं, yes नहीं, wrong है या right है?
Right.
Right है. But your conversation with the vegetable vendor would not go like this. कि अच्छा भैया सब्जी कितने का हुआ? सब्जी हुआ 10 plus 6 rupees का हुआ. Right? I mean, this is not how the conversation is going to go. The conversation is going to go that the cost of the vegetables is 16 rupees. Please give me 16 rupees, right? I can also write this 16 as 9 plus 7, or I can write this as 8 plus 8. We never express a number as the sum of two other numbers as far as possible in our daily life. Sometimes we may, but most of the time we do not, right? अब दिल्ली कितनी किलोमीटर है यहाँ से? 1,500 किलोमीटर है भाई. We are not going to say that Delhi is, 1,000 plus 500 kilometers or 900 plus 600 kilometers. That is something we do not do. Although it is not incorrect. 16 is equal to 10 plus 6. 16 is equal to 9 plus 7. 16 is equal to 8 plus 8. It is not incorrect. It is just not the norm, right? It is just not what we do. In the world of vectors, it turns out that if you express a vector as the sum of two other vectors, then it will have a very beneficial, it will be very beneficial for us. How will it be beneficial? ये मैं अभी hopefully इस class के end तक मैं बता पाऊंगा, right? Don't worry about what is the benefit of expressing. I just want you to be able to express a vector as the sum of two other vectors, right? How do we do that? Well, to do that, all I have to do is for the given vector, I have to somehow construct a parallelogram, टेढ़ा मेढ़ा जैसे भी. अगर मैंने parallelogram construct कर लिया और उस parallelogram के दो साइड में वेक्टर बना दिए, तो ये जो दो रेड वेक्टर हैं, they will add up to the black vector using the parallelogram law of addition of two vectors, right?
Yes.
So the vector A can always be expressed as the sum of vector A1 and A2. Parallelogram law tells us that the vector A is equal to vector A1 plus vector A2, right? Yes?
Yes. So, sir, why we didn't do this in earlier exercises?
Huh?
Why we didn't apply this in earlier exercises?
Which earlier?
We, sir, earlier we did that exercises to add up two vectors. So why didn't we apply this? A vector is equal to sum of.
नहीं तो हम तो कुछ नया सीख रहे हैं ना. We are learning something new ना. How can you apply something retrospectively? I mean, how can you say कि मैं engineering final year में पढ़ने वाली हूँ, why have I not applied it अभी? You can't do that ना. This is new. This is a new interpretation of stuff. This is a completely different perspective of what we have learned. मैंने आपको पहले क्या सिखाया है? What have I taught you previously? I have taught you previously that if I give you two vectors, A and B, and I ask you to add the two vectors A and B, then you will draw the two vectors together, and then you will complete the parallelogram, and then you will draw the diagonal which will be equal to A plus B. Now I am asking you to go the other way around. I am asking you to say that, look, this is the diagonal of the parallelogram, right? Therefore, what are the sides of the parallelogram? Now the vector along the sides of the parallelogram add up to this black vector. You understand the difference of what we are doing? मैंने आपको पहले सिखाया कि अगर ये 6 है और ये 10 है, तो ये 16 होएगा. फॉर एग्जाम्पल, अगर हम नंबर्स की बात करें. अब मैं आपको बता रहा हूं कि अगर ये 16 है तो ये 6 होएगा और ये 10 होएगा. So previously I told you that 10 plus 6 is equal to 16. Now I am telling you that 16 is equal to 6 plus 10. उल्टा कर रहा हूं ना मैं. You understand what I am saying? Hello. आ गई. हैंड रेज करो फिर से, रेज योर हैंड। हेलो, ऐसे मैं नहीं ढूंढ पा रहा हूँ लिस्ट में। रेज योर हैंड तो तभी आपका नाम ऊपर आएगा। हाँ, सो इज
Sir,
दिस,
I understood.
ये आया ना समझ में? नाउ,
Sir.
नाउ फर्दर आई से, right, I say further that if the two vectors are perpendicular to each other, right, if the two vectors are perpendicular to each other and then they add up to the given vector, this is a special situation, right? And in this special situation, the two vectors which add up to the given vector will be called the components of the given vector, right? So basically what we are attempting to do is that we are attempting to write a vector as the sum of two other vectors, and these two other vectors must be perpendicular to each other. Therefore, we end up with property 1 of the components. So, अगर दो वेक्टर एक वेक्टर के component हैं, तो it is guaranteed that the sum of these two components will give you the original vector, right? अब पॉइंट नंबर 2 किसको नहीं समझ में आया था? पॉइंट नंबर 2 उसने बोला था, पॉइंट नंबर 2, रोल नंबर 15, रोल नंबर 15, रोल नंबर 15, पॉइंट नंबर 2 आया समझ में? It is just Pythagoras theorem, right? It is just Pythagoras, base square plus hypotenuse square. Third point, anybody who does not understand the third point, please type no. Anybody who does not understand the third point, please type no. Anybody who does not understand the third point, please type no. Okay. So roll number 12, you do remember, roll number 12, अगर एक राइट एंगल ट्राइंगल है मेरे पास, ये एंगल थीटा है, तो कोसाइन थीटा का क्या डेफिनेशन होता है? रोल नंबर 12, और साइन थीटा का क्या डेफिनेशन होता है? रोल नंबर 12 बताओ भाई, जल्दी जल्दी बताओ, फिर आगे बढ़ेंगे। Base upon hypotenuse. Are you sure? Or is it opposite side upon hypotenuse? Rule number 12. Are you sure about this answer? Have I written it correctly? Opposite over hypotenuse for sine. Okay. Can you see a right angle triangle here? Can you see a right angle triangle here? What is the diagonal of the right angle triangle? What is the length of the diagonal of the right angle triangle? What is the color of the right angle triangle? ये बता दो। What is the color of the, diagonal? Blue. Color of the hypotenuse, blue. What is the length of the hypotenuse? Mod of A, mod of vector A. And what is the length of the base of the right angle triangle? Cosine theta क्या होगा? Cosine theta क्या होगा? Okay, good. right? So I am now assuming that no problems, person. I am assuming that all of you, without any exception, without a single exception, everybody is understanding the contents of the screen. All of you, without any exception, are understanding the content of the screen. Abhi bhi time hai. If you are not understanding, please say no. Okay. Okay. ठीक है. So, अब मैं आगे बढ़ रहा हूँ. Right. I'll move with a question. Find the magnitude of AX and AY if x-axis, y-axis, वेक्टर A, और अब मैं बता रहा हूं, right? I'm telling you in this numerical, I'm telling you that this angle is 45 degrees, and I'm telling you that the mod of A is 10. Please tell me the magnitude of AX and AY. Absolutely, absolutely right. Yes. हाँ, यह है ना सबको समझ में. So, what have I used or what should we use? We should use property 3, right? The angle between the x-axis and the vector is given. Therefore, we should use property 3. Ax is equal to. अब मैं property 3 बोल रहा हूं, but remember that all I'm doing is I'm constructing a right angle triangle here, the hypotenuse of which is 10. And we wish to figure out this side and this side of the right angle triangle. ठीक है? पानी पीना पड़ेगा. हाँ, बिल्कुल सर. Second part of the same question. Okay, I'll write it down in a moment. I'll just speak it now. Second part of the question. The XY axis is rotated anti-clockwise. The XY axis is rotated anti-clockwise by 8 degrees. Okay, the XY axis is rotated anti-clockwise by 8 degrees. Find the new x and y components of the vector. Okay, the vector is not changed. The vector remains the same. The XY axis is rotated anti-clockwise by 8 degrees. Right, so B part of the question. Find X, Y components if XY axis is rotated by 8 degrees anti-clockwise. Right? So you have two choices. Either you can draw the new axis here itself, which will make the diagram very messed up, right? Or, good, yeah. Or you can draw another diagram. बिल्कुल सही. Or you can draw another diagram, which will help you in finding the coordinates. Right? So if I rotate this axis by 8 degrees, ये मेरा नया x axis हो जाएगा. Let me call this x dash. ये मेरा नया y axis हो जाएगा. Let me call this y dash. And now the angle between my new x axis and the vector will be how much? The angle between my new x axis and the vector will be how much? 8 degrees से इसको मैंने, हाँ बिल्कुल सही, 8 degrees से मैंने इसको टर्न किया है, right? So the new angle between the axis and the vector itself must be 37 degrees. And again, I can apply the formula of the third property, and I will get AX is equal to 10 cosine 37. Cosine 37 is 4 by 5. This must be 8. And AY is equal to A sine 37 degrees. So this will be equal to 10 sine 37 degrees, which will be equal to 3 by 4, 3 by 5 hota hai, which will be equal to 6. ठीक है? हम लोग cos 37 छोड़ सकते हैं आंसर, लेकिन वो अच्छा नहीं लगेगा. मतलब अब अगर इसमें cos 31 डिग्रीज आ रहा होता तो बिल्कुल cos 31 डिग्रीज छोड़ दो, फिर तो पूछना ही नहीं है. लेकिन cos 37 अगर आ रहा है तो उसकी वैल्यूज हमें मालूम होनी चाहिए. इट इज एक्सपेक्टेड दैट वी नो. ओके, नेक्स्ट क्वेश्चन इसी का सी पार्ट है. फाइंड AX and AY if axis is further rotated. मतलब कि 8 डिग्री तो रोटेट कर ही चुके हैं, अब फर्दर रोटेट कर रहा है. फर्दर रोटेटेड by 7 degrees anti-clockwise. हाँ 3, 4, 5 राइट एंगल का स्क्रीनशॉट लो अगर यू वांट टू कीप इट स्क्रीनशॉट आप ले लो अभी मैं तो भेज ही दूंगा बाद में बट यू कैन टेक अ स्क्रीनशॉट यस गुड यस गुड गुड वेरी नाइस हाँ डी डी further and now this is tricky डी वाला क्वेश्चन थोड़ा सा ट्रिकी है सोचना पड़ेगा एक बार further by 30 degrees anti-clockwise very good yes हाँ yes it will be yes नहीं there will be two components ना you cannot give me one answer दो components होंगे you cannot give me one answer हाँ हाँ yes मेरे ख्याल से उल्टा दिया है 29 रोल नंबर 29 रोल नंबर 40 उल्टा आंसर क्यों दे रहे हो भाई हाँ मतलब x क्या कंपोनेंट होएगा और y क्या होएगा वो बिल्कुल सही बताया हाँ नहीं गलत है ये 13 हाँ ये सही नहीं भाई √2 कहाँ से आ जाएगा okay so let me show you further by 7 degrees would mean that my y-axis is now here and the x-axis is now somewhere here and the angle between the vector is now 30 degrees. Vector and the x-axis is 30 degrees. So ax is equal to 10 cos 30 degrees and ay is equal to 10 sin 30 degrees. This is equal to 5 and this is equal to 5√3. अगर मैं फर्दर बाई 30 डिग्री चले जाऊंगा तो अब मेरा y एक्सिस इधर हो जाएगा x एक्सिस इधर हो जाएगा और ये वेक्टर के अलोंग आ जाएगा x एक्सिस right so now the angle is 0 so ax is equal to 10 cos 0 and ay is equal to 10 sin 0 this is 0 this is 10 right हाँ अब बताओ भाई इसमें क्या नहीं समझ में आया किसको क्लियर है ये बेसिकली मतलब लिटरली मैं क्या कर रहा हूं, does not have any y component. No, because all of it lies along the x axis. Therefore, it does not have any y component. यहाँ पे मैं लिटरली क्या करने की कोशिश कर रहा हूँ कि आपके सामने एक प्रोट्रैक्टर दिया हुआ है और मैं लाइन खींच रहा हूँ और आप प्रोट्रैक्टर से वेक्टर के और एक्स एक्सिस के बीच का एंगल निकाल रहे हो और चुपचाप थर्ड प्रॉपर्टी आप यूज कर ले रहे हो. ठीक है. नाउ if we have a vector like this, ठीक है, इस केस में जब हम ax और ay लिखेंगे, राइट, मैं ये ऊपर से वेक्टर साइन हटा दे रहा हूं, केवल हम कंपोनेंट्स ही लिख रहे हैं. That will be equal to a negative number. Ay will be equal to the positive. अब ये जो ax नेगेटिव आएगा, ये नेगेटिव, ये लेंथ ही आएगी, मतलब वो cos थीटा ही आने वाला है, लेकिन ये आएगा, ये लेंथ आएगा. ठीक है. अगर आपने एंगल यहां से ही मेजर किया, ट्रिग्नोमेट्री में हो गया है कोसाइन साइन ग्रेटर देन 90 डिग्रीज. हैव यू कवर्ड दिस इन ट्रिग्नोमेट्री? है ना. तो cos थीटा ऑटोमेटिकली नेगेटिव हो जाएगा, तो आपका आंसर ऑटोमेटिकली ax के लिए नेगेटिव आ जाएगा. राइट. So either you measure the angle from the positive x-axis, or you can measure the angle from here, but you have to keep in mind कि इसको negative लिखना है. Right? E part. Same question. Further rotated, the xy axis is further rotated by 30 degrees anti-clockwise. तो यहां तक हमने रोटेट किया था, फर्दर रोटेटेड बाय 30 डिग्रीज एंटी क्लॉकवाइज. तो ये जो एक्स एक्सिस है ये वेक्टर के अलोंग ही आ गई थी, ये एक्स एक्सिस वेक्टर के अलोंग ही आ गई थी. अब इसको फर्दर रोटेट किया है हमने, इसको हमने फर्दर रोटेट किया है by 30 degrees, so that now, right now, this is the x-axis, this is the y-axis, and your vector is here. Vector change नहीं हो रहा है, vector वैसे का ही वैसा है, x y axis change होती जा रही. हाँ, आंसर मैंने देखा नहीं है. Yes, yes, yes. Yes, it will be in the fourth quadrant, yes. ये 15 कहां से आ गया? फर्दर बाय 30 डिग्रीज है ना, एंटी क्लॉकवाइज. ये क्या है? ये -5 क्या है? व्हाट इज -5? नहीं, फोर्थ क्वाड्रेंट में है ना. फोर्थ क्वाड्रेंट में क्या पॉजिटिव होता है, क्या नेगेटिव होता है?